What are the chances this works? Nope. Oh, there we go. All right. Fiddling with streaming gear. Cool. Hello, everybody. How's it going? Avian 3 is out, as you can see. So I figure we're going to talk a little bit about Avian to start off the stream. I think we're good. I haven't hit record. I should hit record. I'm going to try something a little bit new. We're going to talk a little bit about Avian 0.3 because it just came out. And I think I'm going to try to cut this up into a YouTube video for the channel. So, yeah. Let's see what looks good here. Cool. So Avian Physics 0.3. Avian used to be known as XPBD. 0.1 and 0.2 have already been released. The other big physics library in the ecosystem is Rapier. Let's see if I can bring up Rapier. So these are kind of the biggest two physics systems. Rapier tends to be more interesting for like deterministic simulation of stuff, like scientific simulation. And Avian tends to be more Bevy focused, Bevy first. Hey, right during the Spain-France championships. This reminds you of your first Chris stream? Nice. What is the champions that you're watching? Championship. What sport and or thing? So today we're gonna completely ignore Rapier because that's not about Rapier today. Because Avian Physics 0.3 is pretty interesting. Avian does pretty big releases in general. So we've been using the main branch for a while. I figure we'll go through the blog post. We'll check out some of the new features that we might not have touched yet. And then we'll go upgrade our application to use it. World Endurance Championship. Is that like car racing or is that bikes? Cars, I would assume, if somebody had an accident. Your cat is named after them? Nice. So there's a list of highlights here in the blog post. Avian 0.3, huge release. Collision events enabled opt-in contact reporting. We've already used this on the channel. You now have to basically put this component onto whatever you want to report contacts, and that kind of merges with the second feature that is in these highlights, the observable collision events, which means that you can use observers for on-collision start and on-collision end. There's new collision hooks. So the collision struct, I think, has effectively been removed and also turned into something else in this release. So collisions as a struct still exists, but it doesn't mean what it did in the last release. You can do per-manifold properties. So you can have friction on like one piece of a manifold, which is cool. Collider context. So like any collider, I think, is like voxel collisions and stuff like that, like things that are not typically viewed as meshes and colliders. Diagnostics are very cool. We haven't used the diagnostics at all yet. Performance improvements, etc. And there's some cool future stuff. So like we just covered, opt-in contact reporting, you have to put the collision events enabled component onto the entities that you want to kind of like observe collisions for. When I say observe, I do mean like an observer, not like have collisions. This is one of the things that's really interesting about required components that many people probably don't know. Register required components is something you can do to register your own components as required components of another component that you don't own. So in this case, whenever a collider is added, collision events enabled would also be added to whatever entity that was. This is very cool. It's very powerful. It's easy to overdo this as well. We've talked about the observers already. We used them in some of the new educational material. We used them in Block Breaker, and we used them in Asteroids as well. So if you have collision events enabled for some entity, then you can run an observer that will trigger on collision start, either local or global, doesn't matter. The example they use here is like a pressure plate, like a one-off pressure plate, where you would want to do something specific for this plate in particular. There's kind of like a collision hooks rewrite. There's a new conveyor belt example, which is very cool. Yeah, Rapier and Avian are pretty comparable in general. I wouldn't necessarily say that one is like the best physics engine ever. They're both viable for different projects. I generally tend to use Avian these days, and I do like it quite a bit. So hooks are something I'm a little bit less familiar with, but these are like one-way platforms and things like that. So in this case, they're implementing collision hooks for some struct. That struct has some queries in it. So this is a system param. If you're not familiar with system params are like things like query, res, resource, things like that. So we're implementing collision hooks for this system param, which presumably brings in those queries. You didn't really get the last sentence in the observable collision events section. Let's go to the observable collision events section. Observable collision events. So the buffered collision starting and collision ended events are still available and are good for efficiently processing large numbers of collisions between pairs of entities, such as playing sound effects on collision or responding to projectile hits. This is the sentence that you're referring to? This is very much like observers are new, right? You can now use observers, but the observer events, if you scan them quickly, you don't notice. But if you look at what they actually say, this is on collision start and on collision end, and this is collision started and collision ended. So the difference between observer events and like event writer, event reader events is they have to be dispatched in different ways. So from Avian's perspective, if they're going to dispatch an on collision start event that you are going to respond to with an observer, that has to be like commands.trigger or trigger targets or something like that. If you're going to use an event reader to process a lot of these collisions in parallel, those need to be an event writer with .send, right? Or I actually don't remember if it's .send right now. So collision started and collision ended are those event reader, event writer events. And on collision start and on collision end are the observer events. That's the only difference there. Basically, the main reason to use something like event writer or event reader over observers is if you're doing batch processing of a lot of things at the same time. So in this case, they're saying sound effects on collision or responding to projectile hits. So maybe you want to limit the number of sound effects that are caused by collisions, right? Maybe you have thousands of, objects and you don't want to play 1,000 sounds because it'll overwhelm whatever, audio library you're using. Hey Zerk, how's it going? Good to see you. Does that answer your question sort of about this sentence? It's basically just that you can do what you did before and you can use Event Reader, or you can use observers. So back into collision hooks. Collision hooks supersede post-process collisions. They seem a little bit nicer than they were previously. The queries that you're making inside of this system param are being passed in as self, so you can self.interaction query get many with some entity IDs and get the results of this query. Kind of an interaction pattern that you don't see very often in like casual Bevy app usage or in tutorials and stuff. But definitely a way that you can definitely use them. Today you tried to use Bevy ECS LDDK with Bevy 0.16 and it's incompatible. You're fairly new to Rust and Bevy, so you're not sure. I think that Bevy ECS LDDK doesn't have a 0.16 release yet. I think if you want to use Bevy ECS LDDK, you have to either use Bevy 0.15, or maybe there is a branch, but I haven't checked. Hopefully I got their username correct. Yeah, I don't think that there is a current release. There might be a PR. Yeah, somebody has a PR. So if you're fairly new to Rust, I would probably say maybe don't try to use the PR. Because when you run into errors, you're not going to know how to fix them is really the only issue there. But basically it's coming, but it's not out yet. Collision hooks, one-way platforms and things like that. So you get to filter out pairs of contacts. So contacts being like collider and collider hitting each other. If you're, say, a character on top of a one-way platform, you want people to be able to fall through but not jump up, you can filter out those pairs of contacts so that they either are processed or aren't processed based on conditions. So once you implement it for your system param, you do have to set that up when you set up the physics plugin. John Dolph is here. Perfect. They can explain it better than I can, for sure. Is there minor changes or major changes between Bevy 0.15 and 0.16? I would say that is a major change mostly. It's not like you're going to update like a dot spawn to a dot whatever. Especially if you're new. If you're new, I would consider like a 0.15 to a 0.16 fairly major. If you're an experienced Bevy user, it might not be as much of an issue for you, depending on the application. Per-Manifold material properties is probably the coolest new feature. Per-Manifold material properties are really cool. I have to be honest and say that I don't fully understand what is defined as a manifold. So this is saying it stores friction and restitution properties for each contact manifold. And you can modify the surface material properties of individual contacts inside of collision hooks. So that all makes sense. There's something that you're colliding with. You're colliding with it at a particular point between two objects, and you can determine what the friction or restitution of that contact specifically is, rather than what it is of the colliders as a whole. Yeah, a manifold is a closed solid, but does that count for, I guess, two colliders under a rigid body? Probably not, right? So it would have to be a single collider. So in this case, a manifold, or like 2 points between manifolds, would be inside of an individual collider. But I also don't know how that extends to like tri-mesh. So some stuff for me to learn for sure. You think it's just the points where two bodies have contact, you can then procedurally modify their properties at that point? Absolutely. That is definitely the high level is when two contacts, right? When two pairs of things connect, at those points, you can determine what kind of friction they have. That is definitely the high level. Contact manifold is basically a contact surface defined by a set of points and a normal. For collisions between convex shapes, there's only one manifold. But if you're, say, intersecting tri-mesh triangles, each triangle would have its own manifold and normal. That makes sense. And this is the new conveyor belt example, which is very cool. This is from the new tangent velocity property. Tangent velocity is on what? Let's take a look. Tangent velocity on the manifold. Interesting. So yeah, I feel like I should get much more, I should get in depth with collision hooks at some point. Play around with them a little bit more. So this is context.manifolds. So this is the contacts. We've got the conveyor belt from a query. We've got a direction for the conveyor belt, which is mostly hard-coded, or not hard-coded, but rather based on the transform rotation. And then for all manifolds, this is interesting. Contacts. Okay, so for all which group of manifolds is this? Is this only the ones that are contacting the conveyor belt, like all of the dynamic ones, or? Let's go to docs. The list of the manifolds between two colliders. Each manifold contains one or more contact points, but each contact in a given manifold is the same contact normal. So is the I feel like I was under the impression that the manifold would be the actual collider, but this seems to imply that there's like an in-between thing. With tangent velocity and contact manifold, we can create a surface that behaves like For example, a rotating fluid dragging around the player. Yeah. What's the best place to discuss Avian-related topics and questions? Probably the Avian channel and the Ecosystem Crates channel in Discord, in the Bevy Discord. So if you don't know where the Bevy Discord is, go to the Bevy Engine website. Discord is linked on the website in the Community tab. And inside of that Discord, you'll find an Ecosystem Crates channel, which has an Avian channel inside of it. That's the best place to discuss Avian stuff. I know John Dolph is active there, for sure. And as are a bunch of other people as well. A contact manifold describing a contact surface between two colliders represented by a set of contact points and surface properties. Manifold can be a single point or a polygon formed by contact points. Okay, so if there are multiple contact points, then we kind of construct the manifold from all of those points. And they will be like per triangle, more or less, because they have to share the same normal. So then when we do contact manifolds here, what we're getting is that imaginary plane between the contacts, not either of the colliders. So contacts.manifolds means we're iterating over those sort of like constructed planes. And then applying tangent velocity to the manifold. That's interesting, I feel like. So we're applying the tangent velocity to the contact plane between the two colliding contact pairs. Does it have shape casting? Avian does have shape casting, absolutely. Hey, you're new here. You'd like to start learning Rust and Leptos. Are there any specific courses that you would suggest? Not really. There's a Leptos book that's around that you can go read for sure, especially if you're just getting started. Leptos.dev has a bunch of stuff in it. It's worth getting through this, especially part 1. I guess chapter 3, part 1 brings up a lot of the stuff that you'll have to get into. Yeah, similar tangent velocity stuff can be found in at least Rapier, Jolt, and Box 2D. Makes sense. So then there's something that takes the tangent velocity. This manifold is a... I didn't look. I should have looked. Docs.rs, Avian 3D. Manifolds gives us the contact manifold. Contact manifold is not an entity or anything. So presumably Avian is taking these manifolds and then applying them to the entities. So our conveyor hooks system param is querying for our conveyor belt in the place that it is. We're using the collision hooks to modify the contacts. If one of these is a conveyor belt, then we continue. If not, we don't. We get the direction using the location and the rotation. Then we go through each of the contact manifolds between the two contact pairs. And we apply a tangent velocity to that manifold contact, which then Avian presumably takes and applies to the actual entities. This tangent velocity stuff feels like something you'd want to be done at the time of construction of the collider and not continuously. Is that possible? You can imagine dynamic use cases though. You can fully do any kind of like force reproduction that you want to, right? If you have at the time of the construction of the collider, you're saying you want to try to place this onto the conveyor belt itself, I guess. And then anything that contacts the conveyor belt would automatically get some function applied to it. Yeah, John Dolph is in chat. Maybe if they have time and hear the question, the tangent velocity applied to the manifold, that tangent velocity is then handled by Avian and applied to the entity that the manifold is contacting. Are these static? Yeah, okay. So the conveyor belts, wait, are the conveyor belts static? Yeah, the conveyor belts are static. So no matter what velocity gets applied to the conveyor belts, they're not going to move. Which is why applying the tangent velocity to the manifold only moves the dynamic rigid bodies. If I'm understanding this correctly. So because it's applied to the manifold, my assumption, this is a little bit of a guess, is that the tangent velocity would apply to both of them. But because one of them is static, it doesn't move. And because one is dynamic, then it does get the velocity added to it. Theoretically, if they were both dynamic, although I don't know what that would actually do for you. If they were both dynamic, then that would apply to both of them. Is it the conveyor belts manifold or the items on the belts manifold? It is. The manifold is the contact points between the two. So if you had a sphere on top of a cube, there would probably be one contact point theoretically, right? That manifold is that contact point. If you had a chair with 4 legs, this is a little bit probably wrong, but if you had a chair with 4 legs that was on top of the conveyor belt, then theoretically the manifold is the plane constructed by 3 of those legs for each of the 2 triangles. In box 2D, the tangent velocity is set per shape and not per manifold in the hook, but that means you'll have the same tangent velocity everywhere on the surface. So it's a bit of a customization thing. Is Avian good enough for robotics, specifically contacts? I don't have the answer to that. I don't know. So you can't do stuff like have a conveyor belt that moves everything towards its center. Might be fine in 2D, but a little bit more limiting in 3D. Yeah. So you could have, due to the implementation here and doing it with the contacts and the manifolds in the collision hooks, this can point sort of like a donut cylinder all towards the center, whereas that necessarily or wouldn't necessarily be possible in other library approaches. That's cool. Manifold is point depth normal. Doing stuff's in Rust and Bevy and switching back. Hang on, I just lost my chat for a second. Doing stuff in Rust and Bevy and switching back to original stack, you feel like you're switching from boss fights to a tutorial. That's funny. You misunderstood what a manifold is, Ben. You thought it's the colliding part of the meshes, so there's 2 manifolds and they're colliding. Yeah, I think there's one manifold effectively. If there's like 1 point contact, then it's 1. If like the edge of the cube was colliding with the conveyor, it would just be the line. If there were 3 points of contact, my understanding is that it starts breaking down into triangles because all the normals have to be in the same direction. Maybe the side of a cube would be a quad, but I actually don't know enough about the implementation to say whether it would or not. But my understanding is as long as there's a single normal, that can be considered a single manifold. But it is this like vague constructed idea of the plane. It is not the actual mesh. Yeah, surface between the two colliders effectively. In practice, a manifold is just a container for contact points that share the same normal for a contact between two shapes. Yeah, so it's like just this thing that is useful. It is not an actual piece of either collider. Yeah, that's why I spent a little bit of time there, because I didn't understand what a manifold was either. So needed a second to actually dive into that. I don't like skipping stuff. I don't like just being like, oh yeah, it's a manifold. Everybody knows what a manifold is, right, everybody? And then we all look at each other and give each other thumbs up and nobody knows anything. For a cuboid face contact, there would be 4 points in a manifold. Yeah, okay, cool. Yeah, so if there was a perfectly flat cuboid on cuboid, then because everything is has a single normal, and 2D shapes are probably easily constructible and dealt with, that is good enough. Because we're not rendering them, right? They're just abstract mathematical shapes. John Dolph is not just an Avian contributor. John Dolph is the creator of Avian and XPBD before it. They really, really, really know what they're talking about. Yeah, you saw manifold and said, don't know what that is. Must be some special concept for the collider. I am standing. Absolutely. I always stand for stream. Isn't the name manifold a bit confusing for the same normal contact points? I guess you have to call it something though, right? Like there's a name for something that is that. Any sufficiently advanced subdomain has its own vocabulary, right? Nobody wants to be continuously saying same normal contact points over and over. Love the thumbs up, Xavier. Any chance you'd be down to do a stream about combining some concepts together? You'd be really interested in how things like Avian combine with Vue Navigator, I'm assuming is what you're talking about, and Bevy Tenua. We can definitely do a Navigator session one stream. I'm at Rust Week next week, so I won't be streaming Monday or Saturday next week. Those are my usual streaming days. So look for probably not this Monday, but next Monday will be the next stream. And then that Saturday is usually when we do kind of like game stuff, random stuff. Would be cool to take a look at the new debugging tools. We will absolutely get to the new debugging tools. I'm very excited about those. I don't know how useful they'll be for me specifically, but I like numbers. Physics picking is very cool. So picking via raycasts. 0.2 required matching render layers between cameras and pickable colliders. So theoretically, the things that we're rendering and the camera that was rendering them had to match on the same render layer, which feels a little bit... Oh, if specified. So I guess if you don't specify them, then everything shows. But if they were specified, that means that certain things aren't rendered by certain cameras. And thus they would have had to match, because my assumption is that they're using raycasts. You're not sure 100% where the manifold term comes from, but that's what it's called in pretty much every physics engine and resource. Yeah. It's just a name for a thing. Any sufficiently advanced subtopic gets its own name for common things. Yeah, okay. That would be amazing. Thank you. All these projects look great on their own, but you're struggling with putting it all together, for sure. Yeah. I think what we've been trying to do is a character collider, or character controller. We started that last week. We'll probably pick that up again next Saturday stream. But we'll see how much I get done on my vacation to Amsterdam. Okay, physics picking. A physics picking filter is introduced in 0.3 to filter pickable entities using a spatial query filter. So does this mean the render layers are no longer necessary? And this filter layer looks completely different than, say, the collision layers, for example. This is a completely different concept. Let's check. So this is the layer mask specifically. So this is effectively the same thing. Interesting. Yeah, render layers aren't used anymore. Are you supposed to match these? Is a question I have. Because you can do collision layers with these physics layers. Is physics layers generic and meant for multiple use cases? Or are you meant to match collision layers and picking layers using the same enums? Yeah, okay. So it's just a generic physics layer. And theoretically, you would have a variant for pickable things. Actually, that doesn't really make sense. So this is just arbitrary physics layer. I'm trying to think of it like if you have multiple physics layers, one for the collision layers and one for the picking, is that reasonable? Or is that kind of, is there an intersection there in those features? These are not related to the query filter stuff from Bevy recently, right? It looks like an Avian specific concept. Yes, this is a physics picking filter is just, it's called a filter. It's not a query filter. It's not used in a query. It is used for filtering picking, actually, is what it is. So would this be applied to a material as well to distinguish sounds? You're going to have to qualify what this is because I think that we've moved on in stream from that. Still some manifold discussion going on. Physics layer. Physics layers are, I guess theoretically you could use them for that. Physics layers are usually used for collision layers. So if you have a bunch of static geometry in your scene, right, you've built up this whole GLTF level and none of it's really going to move ever. You can put all of those things inside of ground or level or something like that inside of this physics layer variant and label it with that. And then there's probably an example lower, maybe before this. Let's check out collision layers. That's probably where the example is. You can basically take those layers and then construct a collision layers where the player will interact with these other things, but it won't interact with anything in its own layer. So you could make it so that all of the colliders that are static geometry don't interact with themselves, but the player can still collide with them. That's what collision layers are. And there's something that you use to define those layers in this physics layer enum. So collision layers, separate concept. This is basically saying a player can collide with static geometry, or a player can't collide with another player or something like that, right? Not relationships, because Bevy has a has a concept of relationships, so I just don't want to use that word. But yes, you're saying basically like if you have something labeled with the player, then that thing can collide with anything, the enemy, the ground, whatever. But maybe you don't want the ground like processing collisions against itself or any of the static geometry. Maybe you've put like 2 cubes inside of each other or something. That's collision layers. And that uses physics layers, which end up just being a bit mask. So basically what this is saying is there's a bit mask here, and these things have to be labeled with those bit masks. Semi-unclear if there has to be a connection to collision layers. I don't think there does. I think you just get to put the mask in here, and then this gets applied to... actually, I should look at that. Right. Physics layers. I don't think this requires component on it. So physics picking filter then. This says an optional component, which is interesting. I guess that we are in a spawn. Okay, so yeah, physics picking filter goes on the entity just like a collision layers would go on the entity then. I don't know why I thought this was a resource. So that will use the layer mask, and then I believe this is meant to be used as a component. I don't remember off the top of my head. I forget how this applies to each individual. I'm not making the connection here from, okay, this is a mask, to how do you label different things with the layers. Manifolds just clicked for lawn. A normal only works for Euclidean space, so it's called a manifold because in simple terms, it's a flat that is Euclidean part of collider. Maybe a question, but when would you use this versus Bevy's standard picking? Is it because an enum and not a component? It's because it uses raycasts and does the physics colliders and not, say, meshes or something like that. If you want to do picking based on colliders that you're adding to the scene, that's when you would start to use this. If you were doing picking based on all meshes in a scene, or if you were doing picking based on UI elements or something, these are all kind of like ways of filtering down picking to only the things you care about, because doing picking on everything can be expensive. So if you only want to be able to pick things with colliders, that's when you would start looking at something like this. If you want to pick any mesh in the scene, regardless of whether it has a collider on it or not, you would probably look for Bevy's built-in mesh picking backend. If you want to pick something else, then you would pick a different backend. Query filter, raycaster with query filter. These query filters also not the query filters from Bevy. These query filters are like the spatial query filter bitmask stuff inside of the Avian. So there's a better way to do it than with Collider? Yeah, absolutely. Yeah, I appreciate John Dolph showing up too. Okay, so yeah, the excluded entities make sense. Spatial query filter mask, I think that I don't quite grasp from the examples. Like the layer mask is a bit mask. And I understand that using it in collision layers, there's no derive for component here. And there's no example of, I know there's going to be an example in the repo. So let's go check the repo quickly. Crates. Let's do 3D. Why not? Examples. Conveyor belt, collider, constructor. Maybe physics layers is in 2D. Here's collision layers. So yeah, collision layers is still just saying I guess what we are, so to speak, and what you're colliding with. But we're not actually labeling with collision layers. So it makes it a little bit confusing from an API perspective to put a mask into here when it doesn't feel like we're labeling anything with a mask. Right? Physics picking filter from mask, game layer MPC, right? But how are we labeling things with game layer MPC? With collision layers, it's obvious because it's part of the API, right? The collision layers defines what the relationship is. Right? Player collides with enemies and ground. Thus, when we put collision layers onto something, it is a player. So I guess we're implicitly... Okay, so it is. Okay, that's what I was trying to figure out. It is tied to collision layers. You can't use physics picking filter without also using collision layers because collision layers labels what things are, right? I was looking for I was looking to see if there was an example of applying game layer player to something without it having collision layers. But I don't think that's true. So you have to use collision layers if you're going to use physics picking filter. It's the membership field, yes. But yeah, I just wanted to be very concrete about my understanding of you do actually have to use collision layers because otherwise these things aren't labeled. Cool. Diagnostics is something I actually want to run an application and go see. It shows the diagnostics here, but I do actually want to actually see it in a real example. So let's get a terminal here. Actually, I bet you there's a demo. I don't know that there is. I'm just kind of assuming that there is. So we have nothing there, maybe 2D. This is one of the interesting things about projects that have multiple disparate crates that ship to crates.io is where do you actually put the examples? Bevy has the same problem. Collision layers, colliders. Debug dump. There's a debug dump for both of them. Let's try 3D. And in the meantime, cat creates Avian 3D examples, debug dump. Oh no, that's the schedule dump, isn't it? So not terribly interesting for us. We'll stop that. The example's called Diagnostics. Cool. Diagnostics examples. Cool. So physics plugins, default plugins, physics diagnostics plugin, physics diagnostics UI plugin. There's a whole thing that Bevy kind of has where it has this diagnostics store. This is where things can kind of just put diagnostics for later. And then the typically what happens is you have a UI plugin for those diagnostics that you also need to add. Frame time diagnostics plugin comes from Bevy. And it looks like there's a resource here that can turn the UI on and off, which is really nice. I do really like being able to turn these kinds of debug UIs, even Bevy Inspector eGUI on and off. So it does look like it's as easy as that. Just add the plugin and you're done. Assuming that I didn't pick a recently merged PR here. Let's see. No method clone found for intro-iter in Bevy ECS index map. Interesting. This is using 0.16. This isn't moved to main yet, has it? So yeah, I missed a little bit of chat doing that. Yeah. Yeah, you do like how the UI part of the diagnostics is all set up for the user. Yeah, IS Perf UI does a similar thing, and I really like it. You're out of the loop and just arrived. What's Avian? Avian is a physics crate for Bevy. Similar to, you might have heard of Rapier. It got a 0.3 release, which is something I consider a major release. So it's pre 1.0, so 0.1, 0.2, 0.3. Are all things that I consider major releases. Does feel weird that that would be the issue. I don't think that was the issue in the Bevy ECS. The Bevy ECS issue here is strange. It makes me feel like there was some kind of update, or maybe not update. Maybe I'm on too old of a Rust version. Are we updating Rust? 2021 features. Yeah, you're familiar with Joy and Rapier. Yeah, so it's like same kind of thing as Rapier, physics engine. It's a little bit more integrated with Bevy. I like it quite a bit. Would definitely suggest checking it out if you haven't. But also, nothing wrong with Rapier either. For you, just cargo run example diagnostics works. $228. I'm a little behind on Rust on cargo version. Let's just if you want to update Rust, you do Rust up update. This will take a second, but then we'll try to run the example again. You're fairly new to Bevy and Rust. You were using a patched version of Oxidized that works with 0.16. You tried Avian 3D in a project and it broke batched Oxidized version. You were curious if you could provide some insight how long it takes ecosystem to catch up to a new Bevy release. Typically, major crates update pretty quickly within a couple weeks. Typically, the cadence is there are some people who are very, very on it, and they participate in the release candidate process, and they usually have a release either on the day of 0.16 or within a week or two of 0.16. And then there's people, maintainers who do this in their free time. They wait until the stable release to start working on a 0.16 port. Sometimes they get busy, sometimes they're whatever. So it really depends on the particular maintainer. And how complex the crate is as well. So I've got to have some junk around from a previous Avian install or something. Yeah, so basically there's going to be a jam. The jam is going to happen on June, like the first week of June, like May 31st, it's going to start. Typically everything is updated by May 31st. Everything that you would want to use in a jam. But things that are kind of like edge of the ecosystem, like Oxidized is not necessarily central to the ecosystem. Yeah, I'm going to do cargo update next. I haven't updated Rust in a couple of months, I think, actually. Contrary to what I should be doing as a good content creator. So yeah, I would say that like there are crates that everybody uses. Things like Avian update pretty quickly. For example, Bevy ECS tile map is one I maintain. I make sure that it has a release within the first, like I usually participate in the release candidate process, but it really depends on the maintainer, how much time they have, etc. Yeah, they were working with a fork, but I think the issue is that they are new, so they don't necessarily know how to update code themselves yet. Kind of like an inexperience issue. So they're kind of relying on somebody's PR. That PR no longer works with an update for whatever reason, which is understandable. So I think their best option is to actually just go back to main go back to the version that works until Oxidized updates. I don't know when Oxidized is going to update. I'm not familiar enough with the update cadence of that particular crate. I do know that, I think it's a navigational crate, right? I do know that Vlu Navigator is handled by Francois Mockers, who is related to the Bevy project pretty heavily. So I would expect that to get updated. But yeah, if at the end of the day, crates get updated when their maintainers can update them. And the best thing you can do is actually just submit the PR to like fix the issue that you had, right? If you have something that worked, you know, last week or whatever, and because something published the stable version, one API changed or something, that's probably a pretty small diff. I would just look into the issue and see if you could fix it. But I totally understand that if you're inexperienced, that's very daunting. Mick Lilsey, I really like Avian. Been a while since I used Bevy, but I remember using Avian and it was great. Had a slight problem, but talking to the creator was really pleasant. Yeah, John Telf's great. They're very kind. They're very helpful. And they do a lot of great work for the ecosystem. Maybe unrelated, but have you seen the GDC talk of Spacetime DB? I have not watched the talk yet. There was a, yeah, I think my computer's dying actually, Lon. Is really the issue. I think this one's on me. It's an M1. It's getting old. So here's the UI. It's a little bit unfortunate that we don't have like, command plus, command minus for UI. But here's the UI for that stack of cubes. We get the physics steps, number of dynamic, kinematic, and static bodies, number of colliders, number of joints, contact pairs, contact constraints. The time it takes for broad and narrow faces, cool. Solver time. I noticed that in the blog post. We'll talk about that later. There's no swept CCD. Continuous collision detection is what that stands for. It's a stack of cubes, so I wouldn't expect it to be there. This is very cool. It's really cool to see like all of this laid out like this. So if I had a big, large project with, you know, a bunch of physics stuff and I wanted to look into what was going on here. Very, very, very cool. Yeah, the compilation speed launch. My computer is just kind of like dying or something. I've noticed everything on my computer getting slower and slower. So I don't know. M1 is pretty old now. We're on M4. Yeah, I think the new Mac Studio is just like better than any M1 could be, right? So yeah, I mean, like if you can buy the lowest end whatever computer and it's better than the old Pro, then it's old. I need to get a new computer. I also run a lot of stuff on my computer at any given time. I should probably stop doing that. I leave VS Code open all the time too. So I probably have like 20 Rust analyzers running. And that's not really an over exaggeration. I probably literally have 20 Rust analyzers running. I should be better about closing stuff out before stream. Yeah, so why not Tracy or Flame Graphs for like profiling? They're great for profiling, but it's so much easier to set up the UI we just looked at compared to setting up Tracy or running flame graphs. For just like a gut check on what's happening, I love having this UI. Integrates with Bevy's Diagnostics store like we saw, and then is basically just gives you the UI. Can be turned on and off via the resource. Perfect. Wonderful. Love it. These damn software developers. Yeah. It's me. Does Avian allow add-ons? If you want to make an Avian crate for simulated fluid physics, please call it something else. Please call it Avian fluid or something. Probably more of an OS install age issue instead of a hardware issue. That could be too. I don't think I've updated my OS in a while. Yeah, we're probably on like 15 or 16 for OS version, right? Let's see, Mac OS version. We are on what? What's the latest? $15. So we're 6 months into 15. Yeah, I'm on 14.2 right now. So might be time for me to upgrade my OS. You didn't even mean update, you just meant never removed a ton of stuff? Yeah. Here's his sub-second. We were doing a full clean compile. So we're not going to get sub-second times on a full... That was not just a full clean compile. That was like, I installed the latest version of Rust and then did a compile. So like we did like a full clean compile. Oh, you were responding. Okay, yeah, gotcha. Yeah, incremental should be pretty fast. Your iterative compiles being 30 seconds is definitely indicative of an issue. 30 seconds is too much. I'll never close my instances. I'm getting better. You see how many desktops I have? It's only 6 on that monitor. We're going to ignore the other monitor, okay? We're not going to talk about the other monitor. We're going to focus on the 6 that are on this monitor. I didn't even do that on stream, so you don't even know how many there were. Yeah, I keep too much stuff open, for sure. Okay, so reworked contact pair management. This is, I think, all of the performance work that was mentioned earlier. Reworked and optimized contact pair management, reduce allocations and unnecessary work, increased parallelism. That was a weird way to pronounce parallelism. Allowing more efficient contact access with a given entity. I think we'll skip the deep dive for the stream. But the deep dive is here in the blog post. These blog posts are very good. I would definitely suggest reading them if you're interested in them. There's mention of simulation islands, which this work is a base for, but there are not simulation islands yet in Avian. So basically all that turns into a contact graph. It's based on the pet graph ungraph. Although I don't think it is actually the pet graph ungraph. I think it's just based on. I didn't actually check. So collisions, the old collisions is gone. The old collisions resource is gone. The new collisions is a system parameter that wraps the contact graph that we just skipped the explanation for. So it's its own standalone system param now. Activate pressure plates in this example. Query with pressure plates. For plate inquiry. For contact pair and collisions with pressure plates. So this is looking for all pressure plates. This is iterating over them, checking to see if there's a collision with any of them. If there's enough force on it activating the pressure plate. Or printing out something. This would generally be like a commands.trigger or something. When did I do my last reboot, full reboot? We're 8 days. 8 days. Unfortunately, before that, it was much higher. Oh, just full restart. I don't know. Unlike in past releases, collisions does not allow mutating or removing contacts. This limitation is intentional, as contact modification and filtering should typically be handled via collision hooks. So contact modification and filtering, we talked about collision hooks earlier, building that system param. That's when we were talking about manifolds and stuff. So it looks like collisions is if you need to query for something and like trigger something, so like a pressure plate or contact with a target or, you know, something like that, you can use collisions. But if you need to build a one-way platform or a conveyor belt or anything like that, collision hooks. Performance, old, new. I'm not going to focus too much on these, just in general. I think that they got better. It's really all I'm going to say. Please do a full yeah, I will. I'm going to do one before I leave for Rust Week. I'll do a full restart. I'll take my computer on the plane, and then I'll do one when I get back to. A year uptime? I definitely... Oh, you know why I restarted 8 days ago? I remember now. My laptop crashed. That's why I restarted 8 days ago. Literal blue screen crash. Like, hard crash. Your record is 1.5 years for a computer? Wow. That is not something I've ever done. I'm not on Windows, no. Well, I mean, the computer over here is Windows, the computer over here is Mac. We're doing all of our work and stuff on Mac. We're doing streaming on the Windows. All of you are attached to the Windows monitor. Improved contact types. You might have noticed from some code examples, contact types have undergone some changes. Just some renames, it looks like. Rename. Some new helpers. New flags. Contact manifold now stores a single world space normal instead of 2 local normals. That's cool. I love the simplification. Interesting to consider, I guess, which direction that normal would be in. I guess in some sense it doesn't matter. which is why it got simplified. Per-Manifold material properties. From the first shape to the second. From the first shape to the second, which you don't necessarily have control over, right? So if we were doing this in hooks from earlier, it would be from the one with labeled 1 on it, right? Where's our hook? From entity 1 to entity 2 is what you're saying. Or collider 1 to collider 2. Collider context. This is the voxel collider stuff. So custom collider types with additional data from the ECS. For example, a voxel collider. Previously not possible. Any collider is something I've never used before, so I've never seen this trait. There's a new context associated type with the trait, which looks like this down here. These are lifetimeless queries, effectively. That's what the squery sres is. Allowing you to specify a system parameter to be passed to methods such as AABB with context, contact manifolds with context. So you can kind of request any kind of data you want. And implement your own collider type and provide any of that extra data, I guess. Right, this is self-content, yeah. So you get that data if you are fetching the AABB from this collider, presumably, or if you were getting the contact manifold. This doesn't look like you need to do any computation. Yeah, to get the other normal, you just negate it. Yeah. Yeah, any collider is mainly for nice voice custom SDF colliders, which is a whole interesting project. But you've seen at least one other person have a custom collider too. Yeah, I don't really anticipate building my own colliders. Maybe I would build my own colliders, like if I was playing with SDFs on a more tech demo level. But I also think that for the use cases that I can think of, just dropping a regular collider on would satisfy a lot of use cases too. Compute contact manifolds. So you have to compute the manifolds and return them. So if these are touching, you have to actually do the computation of the manifold yourself and then return a contact manifold. Makes sense. Basically, for custom colliders, Avian can't possibly know if they are touching unless you say they are touching. And if you say they are touching, then they are touching. Collider of relationships. So Bevy 0.16 introduced relationships. One-to-many entity relationships. Like it says here, the parent got changed to child of. So there's child of and children. And now collider of is for rigid bodies. So any collider that is attached to a rigid body, is my understanding, has collider of as a relationship. When adding a collider, collider of is automatically inserted, which is sweet. So if you have a collider, then next to that collider will be a collider of. That collider of will point to the rigid body that it's a part of. That is just really useful. No like trying to figure out which rigid body is associated with. Just direct access via 0.16 relationships. I love that. Rigid bodies now track which colliders are attached to them with rigid body colliders component. It's a relationship target. Yeah, analogous to children. So rigid body colliders is the children of colliders sitting on that rigid body entity. Collider of is the child of analogy for all of those colliders. So that's very cool. I love that. Random bug fixes and stuff, you know, performance improvements. Entity disabling is new in 0.16. So taking that into account would be new. Hey, Ramirez Mike is in chat right now. Use Bevy's faster transform propagation. And then, yeah, in progress work. So solver bodies, I think this is performance work, future performance work. Just to be clear, we've gone from 0.3 release to stuff that is currently either in progress or stuff that is happening. Solver bodies, performance improvements. 3x improvement to the solver is nice. So yeah, this is, as far as I understand it, like the core implementation is done, but chucking it into a release doesn't necessarily make sense from a maintainer perspective. So this will get some more testing before it actually makes it in. Joint rework, long time roadmap item, long-term move away from XPBD. If you were around for XPBD, then you probably saw the discussion around potential patent risks and stuff like that. Part of the reason that Avian exists as a move away from XPBD. And we end up with joints. This is cool. That's fun. Oh, we can, oh, we could move the chain if we were using the actual demo, but we're just watching the video. Potentially for 0.4, not guaranteed for 0.4. Would be very cool. I haven't used joints a lot in my own work, so maybe I will do joint stuff when this lands. BVH broad phase. OBVHS is like the crate everybody is going to for bounding volume hierarchies. It's D Griffin 91, OBVHS. This is what everybody uses. If you're looking for a bounding volume hierarchy implementation, this is it. The performance improvements in this release are so good. Yes. I love performance improvements. Just nice. Does Avian have something like a tractor? I think magnets. You watch a bunch of dungeon crawlers and their magnet is absolute chaos. I don't think there's a built-in attractor. We were just talking about the whatchamacallit though. The collision hooks. And we were saying that the collision hooks for things that are conveyor belts and stuff could also just point inward. So in my mind, that says a sensor in a given area could be an attractor if you just do the same thing that the conveyor belts do and point it towards the center. So maybe there's not a built-in attractor that I'm aware of, but with these new collision hooks, it sounds like you could just build an attractor if you wanted to. I actually don't know. I don't know if sensors would show up in the collision hook stuff. I'm just kind of assuming they would. Spatial query pipeline rework. This is not PEC yet. Spatial queries directly tied to parry in the collider type. If you worked with spatial queries, you very quickly just start clicking on things and are dumped into the Parry docs. Alternative collision backends cannot reuse the existing infrastructure around spatial queries. Reuse of the OBVHS work would be nice. Void, the same person we just talked about for doing the SDF colliders, has been working on a new spatial query pipeline fully decoupled from Parry that uses OBVHS. That's great. Sick. That's awesome. Love that. And then Peck. Peck is the Parry competitor. This is a demo of Peck that was shared, I want to say it was months ago at this point. I have no concept of time anymore. Peck is a great name. Yes, absolutely. Since the requirements differ a lot, this is for attractors. Should it use Newton's law of universal gravitation? Should the force be constant? Should it consider mass? But it's fairly easy to implement. Yeah, just iterate over entities and apply forces towards the attractors. Yeah. Contacts for arbitrary complex shapes. Wonderful. Really looking forward to the Peck stuff landing. I feel like Parry comes up a lot as a thing that should eventually get replaced. So it's really cool to see that actually happening. And these are analytic solutions for closest to surface normal queries. That's cool. I like this. GJK and EPA implementations inspired by Jolt. 2x as fast as Parry's. Nice. Sweet. So that would be in Peck. No standard compatibility is sweet. I can't remember if the person that I saw doing physics stuff recently, with the like balls dropping into a rectangular container demo, I can't remember if they were trying to use Avian or not. No standard in Parry. So Parry doesn't necessarily have no standard. I assume that Peck would eventually, given that it is made by the same person writing this paragraph. Force rework. Yeah, forces have felt a little bit awkward in the past. I can't say that it's been like a problem. But inserting and removing the components and whatever does feel a little bit weird. What does Parry and Peck do again? Let's go to, do we have a link directly to Parry, or am I going to have to pull it up? This is Parry. Parry is collision detection. It is the underlying library behind Avian right now. Peck would be a replacement for Parry, also built by the people who are working on Avian. Yeah, just collision detection. So if you only needed collision detection and you wanted to use your own low-level library for that, you could go get Parry and you could use Parry if you wanted to. No standard force rework. So this is future stuff. Not really going to get into specifics here, but yeah, better APIs are good. Character controller working group. This started probably like a week and a half ago now. think it started like last Thursday. The Character Controller Working Group is basically a group of people who spontaneously all decided that everybody had the same question and has had the same question for a long time, and that is, how do you build a kinematic character controller using Avian? A bunch of people have already done things like that. Some people have already submitted PRs to Avian that were not currently merged, just submitted. There's been a bunch of external work on kinematic character controllers. So basically all of those people at this point are sitting in a Discord, which I assume that this is a link to. Yeah, this is a link to Discord. Building kinematic character controllers. I think the original goal is like do collide and slide in a robust way, and get that into Avian upstream, and then from there move on. So very exciting that that would be built in, because the algorithm itself isn't that difficult from like a overall perspective. I think the edge cases can get pretty hairy depending on what you're trying to do. I think that probably most people are going to want like an out of the box character controller for a lot of their initial work. So making it easier to build them with higher level tools is very, very, very cool. And that's Avian 0.3. So I'm very excited. I've thoroughly enjoyed the observable collision events already. The collision hooks are something I intend to get more into. I want to mess around with the collision hooks quite a bit more. I don't think I have any use cases for per-manifold material properties at the moment. But maybe I'll come up with one at some point. A conveyor belt with a snag in it, maybe. Like if you were building a factory, a physics-based factory sim that had conveyor belts, where the conveyor belts could wear away in certain places. There you go. That's your implementation of per-manifold material properties. If you are contacting on top of the area that needs friction, then all of your stuff starts sliding off the side of the conveyor belt. What do we have here? We have the... Probably just start updating stuff to 0.3, right? Since it's a 0.3 day. I'm just going to run this. Or just a conveyor belt that has curved parts. Because you would want the friction to be higher on the left-hand side than the right, kind of thing. I think through that. Per-manifold material properties, friction and restitution of collider can be configured with the components, yada yada. What if you wanted the material properties to change based on the entities involved? Each contact manifold has a friction and restitution property, allowing you to modify properties of individual contacts. I feel like that would just be the tangent velocity though, right? Oh, you want the tangent velocity to point in different direction at different parts of the shape. trying to work through a conveyor belt in real life in my head, if you can't tell, and determine, because the angle of that turn is always the same, right? Because it's a single conveyor belt. It's just that it spends, like the outside moves faster. So I guess that would be it, right? If it was turning and if it was a curve, then the outside would have to move faster than the inside. Yeah. So the tangent velocity, not necessarily pointing in a different direction, but being a different magnitude. So use a path spline based on where the contacts are, sample the path, and calculate a vector in its direction. Yeah, you get full query possibilities here, right? So you can query anything you want, right? If I remember the function signature here. Yeah, my hooks lets you query whatever you want. So you can query for the locations. One thing you don't get about the conveyor belt example earlier, you assume it's done for the example, is why the conveyor belt isn't actually a moving belt collider which has a large friction. Probably just to show off the example. You started writing that before the stream moved on to the conveyor belt. Now is a great time for anybody that has questions about stuff. We can definitely go back to whatever it is. You don't want the actual body to move, just the surface. Yeah, so definitely for like unidirectional conveyor belts, you can do a panning texture to make it look like a conveyor. And then you just have this example makes them move. And that, I think, is probably the simplest way to achieve it. If you did a full Jolt has a cool conveyor example, maybe we'll take a look at that. Conveyor belt demo multi-threaded. Let's do the regular one. So here's Jolt's conveyor belt example. The rotational one is just really fun. I don't know what the setup is for a lot of these, but the red plane is very cool. The red plane rotating is very cool. You're saying, sure, but the body and the surface can be separate entities, one of which doesn't have to have a mesh, right? So you're saying that you would rather have a sensor, and when it's colliding with a sensor, apply a force and have like a high friction on the surface? Trying to think about how you would do that. Like, you definitely could do like a moving platform, right? So if you manually modeled out a bunch of panels and then put them around like an actual conveyor, then you could get actual conveyor movement out of two colliders and friction. Is there a debug feature in Avian that can visualize manifolds, contacts, and display, for example, a tangent with gizmos? You could probably just do it yourself. Right? Like if you had a collision hook. Oh, here's the example, our example. This is our collide and slide using Avian 0.3 now. Our sphere or our shapecast. Can you draw gizmos with commands? You can draw gizmos in two different ways. You can spawn them in, which are, then they behave like meshes and whatever. Or like in this example, this is just running constantly. So every frame, these are getting drawn repeatedly. You don't do it with commands if you're doing it immediate. You do it with something called gizmos, which I can actually show. Because it should be right here. Gizmos. So this is gizmos, right? System param, gizmos. And then you just do gizmos dot whatever. In this case, we're doing primitive 3D for the shapecast with an isometry, with the shape that we want to draw, and a color. So this runs every frame, every time this function runs, every time this loop runs, this runs. So that's how we are drawing these gizmos. Not 100% sure if we can actually do the red plane from that example at the moment. Jolt has both a linear and angular surface velocity. But we, meaning Avian, like Rapier and Box 2D, so Avian, Rapier, and Box 2D only have linear tangent velocity. So you would have to constantly modify the linear tangent. That's what I was thinking though. You were saying curved conveyor earlier. So if you had linear tangent velocity for the contact, right? It would have to be relative to the position on the red plane. But if you did the tangent velocity for the manifold, I guess it's per manifold. So you would have to have different manifolds for that to work. Because the entire, say like, I forget what the example was exactly a second ago. I think it had one long cube, didn't it? No, it had a bunch of cubes. So this would work, I think. Right? Because each of these individual cubes can get the tangent velocity constantly updated in the direction that it needs to go. If it was one long collider, it would be one long manifold, and thus you wouldn't be able to because it would be on both sides of the rotation. Obviously, angular velocity would be better. But I think this particular demo, which is just a bunch of individual cubes, as long as it wasn't crossing over the midpoint, would work. Like a moving platform, but each straight section would only need two colliders for the belt itself, each moving along and cut off at the end of the belt. Once there's zero width, they get teleported to start. Each straight section would only need two colliders for the belt. I can't visualize two colliders for the belt in my head. The belt would have to be a bunch of planes, or like a bunch of somethings, right? Moving along the belt or the conveyor. Yeah, it wouldn't be an issue as long as there were multiple manifolds, but there's only one manifold if you have like one long collider. Like if all of those cubes were the same cube, one long cube, that's one manifold, to my understanding, on this. And thus it wouldn't work because you can only put a linear velocity on the manifold. Because there would be only one manifold, then you wouldn't be able to do that. Adam says it's a weird demo as it would seem more natural for the platform to rotate. I think the platform rotating is one thing, right? But if you were going to do, let's say you had something that wanted to emulate like water tunneling down, right? I could see that being done this way, right? If the middle of this had a hole and that hole was, you know, y minus 10 or something, then you could definitely like swirl things into the center. And you probably wouldn't, yeah, like a whirlpool kind of thing. And then you wouldn't need to like make geometry that could rotate, if that makes sense. You would just be able to make it happen with whatever assets you had. Other idea for implementing conveyors. Each element gets its own collider platform to travel on. As soon as it gets close to a conveyor, they all just move along a spline. I think there's like, when it comes to game development, anything that works, right? That's one of the reasons that I feel like code review can be a little weird. Because like if you're doing code review, it has to be code review for a purpose. And most people's purpose is just something that works. And if it works, then it works. It doesn't necessarily mean that it's the best way to do something. But when it comes to a game, right, if you're trying to do something that people play for fun, as long as people are having fun and the thing you wanted to happen is happening, then it's fine. You know? You mean they'd have to follow each other, no linear velocities, the colliders themselves move and drag the cubes with them through friction. Yeah, I mean, if you literally modeled a conveyor belt, right? And you had panels on that conveyor belt, and they were moving along the conveyor area, and things that landed on the conveyor landed on those panels, and they had high friction, you could definitely do that. Can you make a surface bouncy with the same method? It was friction and restitution, right? Were the two things that we have access to? Or was it friction and... Yes, friction and restitution. Restitution is bouncy. Right. How bouncy a rigid body or collider is. So you get friction and you get restitution. You can control how much it sticks and how bouncy it is. It would be the same for a conveyor with two belt colliders. It's just two moving platforms moving at the same speed in the same direction, so having something touch both is possible. It's just two... Yeah, I guess my thought is that if you have two panels that represent the conveyor belt, then one of them is sticking pretty far off the end at any given time, right? But like you could definitely, if you wanted to, spawn random stuff and have it move in a direction, right? That feels significantly harder to do correctly than the conveyor that we just looked at, right? Like if something is close enough, spawn a platform on which it will land and then have it land there and then only keep it around as long as the thing needs to be in contact with the conveyor belt and move it. In fact, in this Jolter Avian demo, what would happen if there was a long cube and it hits the corner touching both belts? Don't move the player. Let the ground move the player. There was a long cube and it hit the corner touching both belts. I still don't really know what you mean by touching both belts, I think. You're saying that you don't need to model it, you just need to have like two, not belts, but why have it stick off the end? Making the collider smaller should be possible. Right, but like, you're basically saying that if you have a conveyor belt, you can just put arbitrary stuff on top of it to make it a conveyor. And the obvious problem with that in my head is basically if you use two things, first of all, right, then you're not filling up most of the conveyor. So you would end up with a bunch of stuff that was like stopped if it was between the conveyor like elements. And if you want to try to cover all of it, then like the conveyor elements, like you have to have 3 effectively, right? I just don't see how you would do it with 2 in any reasonable way. Right? Like I feel like it's a bit of a reach to say that you would be able to do it consistently with the behavior that you want using 2 platforms. Because like at any given time, one of them is going to be hanging off an edge. Well, if you make them super small, they're still going to be hanging off the edge at some point, you know? Until they reach the end and rotate under, or like whatever you're going to do with them. You're just warping them back, you said. So like, I'm not, yeah, I mean, I didn't continue the conversation on 2. I thought we were still on 1. If I just need collision detection, say for an Asteroids Clone, should you use Avian or should you have all kinematic bodies, or better to fully opt in and make each asteroid a rigid body? If you have kinematic bodies, then you have rigid bodies. If you use Avian and you're doing kinematic bodies, dynamic bodies, or static bodies, those are all rigid bodies. So just to be clear, like if you're going to do anything, you're going to have the rigid bodies. I think that you don't, strictly speaking, need Avian for an Asteroids Clone. I think that we just did an Asteroids Clone on stream Monday. I don't think it runs right now. I think I have one thing. I think respawn is what's going to pop up here. I'll let this run though. And I'll tell you what I chose to do. I chose to go with Avian. Basically, the only thing that requires Avian is if you want a triangle-shaped ship or any collider that isn't a circle or a rectangle, then you need to use a richer collision library or implement your own. Bevy core only really has AABBs, or axis aligned bounding boxes, or rectangles and cubes, or circles and spheres for the intersect volume. So if you want a triangle, you need something else, or you need to implement it yourself, which you can totally do. I chose to go with Avian kind of as a result of that. One of the other things that I wanted to do was use the new observers for on-collision start. These actually worked out really well for asteroids. Because you can throw an observer onto each asteroid, and when it gets hit, you just explode it, and then you're done, and you don't have to track anything. It's just when ship get hit, blow up. When asteroid get hit, like subdivide. when when bullet get hit disappear. It's nice. And you get to use collision layers and stuff like that. So yeah, I also built this entirely out of gizmos, which is cool. We have collision layers here so that only the collisions that are observable are collisions that we would want to have. So like, for example, the ship can only hit asteroids. It can't hit its own bullets. So if the ship hits something, it's hitting an asteroid, which means it's time to despawn it. With one, both together would always fill the entire belt platform. The only thing moving from an outside perspective would be the dividing line between them. I don't see how that's possible unless you're literally like making the meshes different sizes. Is that what you're saying? Like you're basically scaling up one mesh towards the end at any given time? So you basically have, I don't know, that just sounds really weird. You know? Like, I mean, like you could, right? Like you could put two meshes side by side, scale one up until it takes up 100% of the width, despawn the other one, spawn it back at the beginning, like manage adding like the little 5 pixel difference there or whatever, animate all of that correctly, like start scaling that first one back up, despawn the second one. That just sounds really complicated. The other question I have is Bevy Transform Interpolation live? Actually, I think it has to be because Avian's up. Yeah, 0.2. Perfect. Perfect. That is the last release that I needed for the workshop stuff that I'm working on. Effectively, everything can now be scripted and shipped, which is great. So this would actually be 0.3 now. I should have updated these versions before I did this. Oh well. Where are these workshops? They aren't published yet. I've started working on them. One of the things that I'm going to do over the next week is focus on finishing the scripting for them. Then they have to get recorded and published. There we go. So this is gizmo-based asteroids with Avian and whatnot. I didn't do the asteroid subdivide yet, but you can see when the bullets hit, they despawn. When the ship hits, it despawns, and then subdivide the asteroid. And that's all observers. Collision events enabled, which is 0.3. We just covered that, plus an observer. Really, really nice. Yeah, script like video script. Yeah. The workshops will be on Rust Adventure, which is where I put basically everything. I'll make more noise when they're actually published. But this is where I put everything. So all of the games will be on Rust Adventure. The written content will actually be available generally, but the videos require a subscription. And it's set up in a way where you can use like your corporate training budget if you feel like supporting me. So instead of needing to pay for it yourself, you can take the corporate training budget that your company gives you and put it into that. And then I get to make more stuff and you get the stuff that I make. So that's the goal anyway. So 0.3, 0.3. Yeah, I think everything's up to date. Today wasn't supposed to be Asteroids. Time is it? Took 2 hours to go over the Avian release notes. Bevy transform interpolation is really cool as well. Use a random restitution because why not? Some things bounce and some things don't. With one, yes, basically scaling up one collider, be it a mesh or a cube, you get it now. The only thing would be they'd be invisible collider-only entities with the visuals being a separate static. That just feels really weird. Like it would be simpler to have a bunch of small panels and move all the panels and despawn smaller panels as they get to the end, right? One of the things, I don't think I have that version of the game currently. Maybe I can find it really quickly. One of the things that we've done for platforms, we tried to drive, I think I have 0.6, 0.15. We tried to drive like Mario style rotating platforms at one point via linear velocity. Oh yeah, I do have that in a demo actually. Let's do that. Let me find that demo. Sort modified. Sort by. Reflection, scheme test, yada yada, a bunch of other stuff. Scene observer stuff. I definitely should name these better. 3 weeks ago, I make so many demos. Test web, newest project. I think cubes is it. No, cubes is not it. Do RG. Yeah, platform behavior. This one. So here we had animatable curves. The animatable curves originally were position-based. And before we had these hooks, the collision hooks that we've been talking about, one of the things that we needed to do to make these interact, I'll run this, it'll take a second, for both linear and rotating platforms, which are just cubes, was to take the positions that we wanted these things to move into and derive the animation clips. I don't think scaling things is normal friction. I think that like having a thing that exists and moving it would feel like normal friction to me, right? Like if you were going to put things on top and have them carry something, they're probably going to be visual belts, and just make the belt take care of it, fine. But belts are typically made of, you know, things that are small pieces. Like I said, if you did that and you got it to work, then fine, cool. Like there's nothing wrong with that necessarily. It's just probably not the way that I would do it. Yeah, I think you run into stuff relevant like that, obviously. Um, are the joints between rigid bodies solved in a way that allows for multi-body dynamics? Interesting question. Do we have a thing here? A trait for joints. I guess we were looking at joints in the blog post, weren't we? The new stuff. This is future stuff. This is a joint rework. This might be an example in a branch somewhere, but it's not labeled, so I'm probably not going to go look for it. We don't have articulations or multi-body joints with reduced coordinate approaches yet. The approach required for that is quite different from the standard impulse-based joints. Yeah, if you do try it, Lon, definitely like ping me when you like show people. I would be interested to see it if you do it. I still don't necessarily think it's the choice that I would make, but I would be interested in seeing it if you're going to put the effort into actually doing it. So yeah, one of the issues that we had with animation powered physics for platforms is it's susceptible to I don't want to say lag, but susceptible to environmental conditions. One of the things that I've seen is if it takes a second to start up, then because you're doing these derivatives, you're working with the angular velocity or linear velocity, the starting point can change based on how long the actual application took to initialize what's actually happening. And if you do something like maximize the window and it interrupts stuff as it's happening, you can get things in the wrong spot. Which made me semi-unhappy with the general approach here. I don't know that this was a great approach ever to start with, but oh, I did this in debug mode, didn't I? I think we've got everything we need. Yeah, platforms.bin. I think this is just, oh no, I remember what I did. I did this for a clip that I made. So these are animation clip driven with animation curve, linear velocity and angular velocity. So we take the positions, we do an animatable curve with Bevy's new curve support. We do the derivative of those, and then we apply that to the linear and angular velocity. But I think it's not right now. But I didn't necessarily like the approach, because this rotating cube can get stuck in places where it doesn't fully flatten out. If Bevy is kind of like interrupted. Yeah, there we go. See, so now it's like, because we resized it, it got interrupted and now it's not flat anymore. So that was my real issue with this approach in general. You could just correct this, but then it's not really like an animation clip driven thing. And I wanted to be very specific about these platforms. Just seems like a case of wrong time source. Animation events to force sync. Yeah, could do. Could do a number of things, right? I don't really love the idea of needing to force sync, though. But one of the things we could do is have them stick to their positional changes, right? And stuff like that. Have them stick to the actual like transform based changes, and then use the collision hooks. Isn't that an animation clip issue and not a moving platforms issue? It's not an animation clip issue from the perspective of, how do I say this? The curves here, let's look at the rotating one, because the rotating one is where the example shows up. We've got an animation, right? We've got an animatable curve. We are targeting the angular velocity of that. Because we are targeting the angular velocity, it doesn't have a start position and an end position. It's a derivative from the position change or the rotational change for the angular velocity. So we don't actually have start and end positions. We only have, it needs to apply this much to rotate at 90 degrees. Also, I didn't despawn any of these cubes, so they just keep going. Maybe use a PID controller instead. I don't even think we need a PID controller though, right? Because like the ideal in my mind is that these are like art directed in a way. So for example, the moving platform, right? I would want to set up a number of positions inside of Blender, move it from position to position to position to position. And through doing so, if you don't affect, let's say linear and angular velocity, if you're using something like Bevy Tenua, which is a dynamic floating character controller, right? So it needs to have the linear velocity, angular velocity applied to these platforms to have the impact on the character, right? To have the impact on the dynamic body. Right, animating rotation directly works, but doesn't transfer forces. I'm really messing my words up today. Same with the moving platform. If we do the moving platform without the derivative for the linear velocity, it goes exactly where we want it to in the time that we want it to, but it doesn't have any impact on a dynamic character controller. So this conveyor approach could be used instead of trying to drive these animation clips, because the original animation clip is what I wanted. Like I wanted either exactly a 90-degree rotation, or I wanted a a platform to move from location to location to location, right? Even with rigid body kinematic, yeah. Yep. Because if you're moving the transform or you're moving the rotation, you are teleporting, right? You are not doing physical movement. And thus, if you have a dynamic rigid body, it just stays where it is because you're teleporting the thing under it. You're not linear velocity-ing physically. There's no need for the belt colliders to have a start end that's defined externally by the actual full belt. They actually just get shrunk towards the end, and once they're zero width, they get TP'd back. Yeah, for your other demo. Have a target position and a velocity generated by the animation system, then use a pig controller to apply forces to get to that point. I feel like and this may not work for the rotational. I haven't worked it through in my head for the angular velocity version of this or the rotational version. But for the moving platform, I think doing the non-physical teleportation, if you will, with a kinematic body for the platform would work. And then you do the conveyor belt solution on top of the moving platform. And then you have your, this is supposed to, no, there's nothing despawning those cubes. These cubes are not despawning at all. That's why I keep restarting it. I just didn't do that. This is a half-built demo because one of the things we were building in the last cycle is something that had platforms that I wanted to have moving and rotating platforms in it. We were using Bevy Interpolation. It was a dynamic floating character controller. So to get these to have the physical reaction to mess with the dynamic collider, we could either turn it into physical movement, linear and angular velocity changes, or we could keep the position to position, which is what I actually want, right? Like I don't want to implement a PID controller because that's not what I'm trying to do with it. What I want is 90 degrees of rotation with a 1 second delay. Right? Like I want it to go from here to there over some set of time, wait a little bit, do it again, like that kind of thing, right? I want very, very deterministic, very specific movement. So and as we move to a kinematic character controller, this kind of thing gets more interesting as well. Conveyor belt on top of moving platform seems cursed. Why? You're just applying the directional for the moving platform, right? There's no extra thing here. You just have the collision hook for the moving platform. Later. Right? Per-Manifold Properties. Where's our conveyor? Right, tangent velocity. So you set tangent velocity equal to the speed at which the platform is moving, and then you're done. Have another curve animating rotation, but with step interpolation. Oh, you mean like have another like fix this if it messes up step? Yeah, I don't know. I was hoping that it would be a simpler problem. In general, I was trying to use Bevy's built-in support for doing things a little bit more. Where did I just put this code? It's right here. I feel like doing the animation clips. I really want to do the animation clips. The derivatives feel really nice in terms of being able to define different points or different movements and then deriving it to apply to the linear or angular velocity. I guess if you do that, you do need either a pig controller or something like that. You think you saw those approaches already in games? Which approaches? I'm sure that all of them have been implemented in the sense that like anything that can be done will be done by somebody somewhere. The fix it up later tends to throw your character into orbit. Yeah. Well, I guess not if you teleport it, right? But if you start teleporting it, it works for small changes. I guess you would just be hoping that the fix didn't like wasn't too big, you know? Maybe somebody's already done this and I should have just looked it up. That's also a possibility. Oh, that's wonderful. Having some trouble with our layout at the moment. Sorry for the wild. One of the things that I don't want to say that I have trouble with specifically, but there's a huge lack of educational material when it comes to like what should the approach be for different things. There's a great many hacks. But not all that many like, hey, this works this way. In any case, I think character controller, maybe. Should actually get this to be moving instead of. Turn on. Don't open big screen mode on my Windows PC. There we go. I think I have, I might have this backwards a little bit. One of the things that I realized that I was doing is YZX here. Yeah, I saw those comments. I didn't have time to actually like go check them. Opened an issue on Bevy website to improve the example materials, and one of the arguments that we don't have that many how to do X. Oh, is that short for Alice? Yeah, I have a comment on that thread. I haven't checked in on it today, but I got pinged to take a look at it yesterday. Yeah, your comments were about using the wrong normal, right? If I remember correctly. I'm just going to leave this as to what it was rather than change it at the moment. Normal 1. So we're doing first hit here. We are doing... I couldn't tell if you meant like during the stream or as the final result, because you made a couple of comments. The capsule sizes seem fine though. Right? Let me get rid of the extra thing here so that we actually get this spawning in a reasonable area. Right? Like the capsule size is fine. So I wasn't sure if you were responding to like something that happened during stream. You think the normal is going out from the cast shapes, so go towards the collision object. Yeah, I mean, they do have the capsule size as length and Bevy uses half length, but they are the same size, right? Like, we have that already, as far as I know. Capsule 3D, 0.5, 0.5, shape caster. Where's our collider? Collider capsule. I guess we do have the same size. I disabled the camera because the camera was really awkward to have. Oh no, I didn't disable the camera. I changed it. There we go. Which one of these is rotation? Oh, I rotate, that's why. Yeah, I think these are the same size. I mean, they would be wildly different if they were different. They wouldn't be like almost the same. I think that I think our calculations here are generally correct. This one's really interesting to me, actually. Because this corner... I've moved the camera around ages. This corner feels weird in terms of that collision. So that does feel somewhat like we're using the normal of our capsule. We should visualize the normal. That would make this really easy to figure out. Let's do it. Normal 1, first hit. The KCC Working Group has been wanting a debug visualization like that for remove and slide. Later, Mike. Thanks for showing up. Yeah, I mean, it's just 2 gizmos. I'll check in and see if they need the code that I have here. I kind of got the impression that they are further along already than I am here. But yeah. I definitely did that because I don't work well holding everything in my head. I need visualizations. So first hit, right? We've got our loop here. We've got the number of iterations that we're going through. Spatial query, cast shape. Here's our hit. What do we have on first hit? I don't remember. We have distance, entity, normal 1, normal 2, 0.1, 0.2. So the question here, if I can find where I have a Chrome window open, that's a problem I need to get better at. I like close everything that I want to use when I'm done with it, and then I want it immediately again. docs.rs/avian 3D. This is, what type is this actually? Shape hit data. Outward surface normal on the hit shape at 0.1 expressed in world space. Outward surface normal on the cast shape. So the hit shape is what I want. I think that do we have the hit location here? Or do we need to calculate that? We calculate that later, right? So if we do this, I'm going to make this another arrow. We're going to make this the first hit gizmo position is going to be our origin. And then we are going to do first hit dot normal 1. And we'll make this I think red is free in terms of arrow color. Yeah, I keep seeing everyone talk about how Parry is misreporting normals. It's part of the reason I wanted to check. This feels like I've picked the wrong spot. Which I have because I need to add the normal to the current position. Right? Because it's origin plus next. It's not offset. I really wish it was offset. The number of times I've made that mistake is very high. So that looks right. And then we get here and it like rotates around the corner. Which does feel weird. Like the flat surfaces are obviously correct, right? But there is, I guess that's the interpolation around from face to face. But the direction that I would want to go in doesn't feel like the orange one. Do you have that set to a hard edge in Blender? I don't know, we can check. You wonder if it's because you use capsules, as opposed to what? So another question I have is basically like, so the Collide and Slide paper uses a capsule, but really squashes it into a space where it shows up as a sphere. With Parry's implementation, it's expected that casting this shape at an edge like that returns the edge normal rather than a face normal. Okay. So then that's correct, because that is what it's doing. And it does just seem to be like interpolating between the two faces in like the way that I would expect it to. So I guess that's just correct, right? That we'll treat that as correct, so to speak, rather than trying to disagree with Parry. It's really the separating axis returned by the GJK algorithm. That's the other thing I want to do. I was just looking into SAT and stuff last night. I think I'm gonna do some really basic implementations and maybe make some videos out of them to firm up my understanding of what's actually going on here. Correct until proven otherwise. What's the green gizmo on your capsules? That is the cross. No, it's not the cross. It's the up vector before the cross. This is the green one right here. So when we get a hit from our shape cast, we get the position. What are we calling origin here? We're calling origin. Origin is the position that we are casting from. Which is probably wrong now that I think about it. Position we're casting from. And the first gizmo hit position. First gizmo hit position is origin plus distance and direction. That feels wrong. No, okay. Sorry, I was reading the wrong one. I don't know why I was reading the wrong one. I have a lot of gizmos in here. So it's a gizmo hit position plus the up-down vector. The up-down vector is the gizmo hit position minus where we are crossed with the normal. So it should be the up vector at the position that we hit. And then we cross that. Why are we crossing this twice? And then we cross that to get the new direction. Locally, you have helpers for computing actual face normals, the surface normal query stuff from Avian 0.3 post. But you're not sure you actually want that for move and slide. Yeah. Yeah. The implementation I'm doing of, this is the other thing that's like kind of weird. You can hit the edge of, like the bottom of the capsule can hit the top of a platform. And if it does that, it does the same thing we were just looking at, but bounces off in a very weird direction. It's again the edge normal, right? What do you mean by again the edge normal? Oh, yeah. It's against the edge, but it's also the bottom of the capsule, not the side of the cylinder, if that makes sense. If you're pushing the character at that edge, you want it to kind of roll around the corner, not cancel out all velocity along some face normal. Roll around the corner. Yes. I think that in general, the behavior that I would want if you were like most of the way to the left going in this direction is that we would move you and you would slide along this wall. You wouldn't get stuck on this corner. I do think that's the behavior that I would want. In which case, this normal doesn't really help all that much. And I have like a lot of situational thinking to do about like the, if you hit a corner like this, the normal sticks directly out from the corner. How do you tell that the movement is a corner in that situation, right? Like tripping upstairs. That's how I feel about writing character controllers, yeah. Does the raycast get you the entry and exit point into a shape? The entry and exit point into a shape. The raycast does not push into another shape as far as I'm aware. Yeah, okay, so that's the thing, right? Like I could do anything, right? There's a number of things that I could just like arbitrarily code here that might work for this exact situation. But, and I think this is where the general lack of educational material in the ecosystem comes up. Like, what is quote unquote the right thing to do, right? If you're moving at this corner and you are mostly to the left of the hit point, then you should probably slide in and keep going along the wall like that, right? If you're mostly to the right, then you get stuck. But if you're mostly to the right, that goes in the right direction, generally speaking, I think. It just doesn't hit anything, so we don't see the second hit. We don't visualize the next step if we don't actually hit anything. So like if you hit this wall, you will keep going along this wall. If you hit the corner, things start to get weird immediately. My perspective is terrible. Yes, absolutely. I could definitely move the camera. Sorry. I know what's happening here. I don't need to see it, but I'll do this so that people can actually visualize what's going on. So if you hit the wall like this, the normal faces perfectly out from the wall. This is like regular, easy mode collide and slide, right? We don't see the visualization, but this visualization in this case goes down off the monitor, parallel to the wall. That all works. Same thing if we do this. If we hit the other wall, it goes along the wall. Ignore the green one. The green one looks like it's careening off to the side. It's coming straight up. The camera is just in a different place. So like the collide and slide with a wall works. This would... I think that part of the thing here is also this visualization is significantly longer than this is actually going to happen in practice. Like this would be like such a massive velocity to be hitting this corner at. Yeah, exactly what you're going to say here, I think. This is only really a problem if you're moving really fast, and so if you're walking, the movement away from the wall will be small enough during that frame that you probably wouldn't notice it, assuming you keep walking to the wall afterwards. Yeah, so a player is going to walk into this wall, probably still hold the direction into the wall, and just like do that, right? They're going to come around this, and they're just going to keep going straight. So I don't know that there's actually a problem here. Obviously, if you came directly at and hit exactly on the corner of that wall, you would stop. Similar to like if you hit like perfectly parallel here, you would just stop. But I think that's fine. Like that seems intentional. So I think the next step is actually turning this from a visualization into actually working. Because it seems like it's working. The one thing we also don't have is gravity. So there's that. So the question here is, let me get rid of this because this code is no longer necessary. But yeah, this is an interesting edge case, literally. Yeah, so for me, somebody who really likes to like build up a bunch of test cases, like figure out what actually is going to happen, the lack of pedagogical material for how these character controllers like could and should work in different ways is kind of frustrating. The fact that I basically have to like stumble through it to figure it out is definitely not my favorite thing. But it's fine. I'll just write 5 character controllers and then I'll have a better grasp on it. Welcome back. So we have this casting function. This casting function currently happening in fixed update. We have our character. Presumably we should be working with linear velocity, right? So current linear velocity. So we have our origin, we have the direction that we are supposed to be going in. Or this is our facing direction, actually. We can get the direction that we're actually going in from the linear velocity. Oh, hey, Chris, did you see the issue about better use case examples in Bevy? As in, how do I show this common task style examples, not just showcasing this API stuff? Yes. I got pinged for that yesterday. I left not like a super lengthy comment, but I left some comments on that for sure. I haven't looked at it today, so I haven't seen anything in like the last, let's say, 12 hours, 12 to 15 hours, probably. I think the last thing I saw was there was some conversation happening. I made a comment. Ice Sentry said that they basically agreed. Alice said that they would prefer to not have examples in a separate repo, and that's about where I cut off. But I need to go back and read that if people are saying stuff on it. We actually have the velocity for the player here already. Desired direction, casting. So the question here is, we are getting movement from, as input from Bevy enhanced input. That's giving us a move direction. So the desired direction is being triggered from that velocity. We don't want to use linear velocity. That's what okay, yeah, never mind. This is going to be not linear velocity. I mean, it's going to be linear velocity, but it's not going to be like linear velocity. I think I named this KCC velocity. Yeah. Right. KCC velocity, vec3. That's what we want. Did I put this on my controller? Is an open question. No, we didn't put it on anything, so it's nowhere. So let's get this in here. KCC velocity default should probably just be 0. We can derive that. Why did I not derive that? We'll derive that and reflect it like good citizens. Default velocity is 0. It gets inserted on the character controller. Now our query will pass. This is no longer true. KCC velocity is what we want here. Agree on lack of learning materials. You really like it if one of the side projects of the KCC work for Avian was to gather a bunch of edge cases and features and make a write-up of how we handle them. I would love that. I would also love to participate in that. If there's any way that I can be helpful in any way in gathering stuff or producing stuff or writing stuff, that feels like a very useful thing for me to participate in. I made how to change the material of a GLTF example given how often it crops up. Yeah, that's been in the examples directory for ages now, right? People definitely like that one. How should the slide work? Can the character boost where it then slides? You mean should it, whatchamacallit? The slide, as in like the final application, should be a velocity that we then modify the transform off of, is how I'm thinking about it. This velocity is not going to be Avian's linear velocity. There was some conversation in the KCC Working Group about whether linear velocity was usable or not in its current state, and I think the answer is no, because it automatically applies. Which on some frame of reference is fine. But it doesn't stop when the player stops, for example. Neither does the apply movement that we're doing here, though. So I don't know. I would like to use more of Avian's components rather than fewer. It feels a little weird to have KCC velocity when linear velocity does exist. But I don't see anybody else trying to use linear velocity either. Might as well ask this here since you thought of it. Does anyone know how to destructure a single query directly in a function argument? You can't, I don't think. I don't think it's possible. I think you have to call into inner. I think that's generally possible, or generally not possible because of the way that Bevy wraps structs in like mute and whatever. But yeah. So new velocity, we'll stick the velocity in here for now, I guess. Right, and this will just be velocity. This is just gonna override it completely. Probably want something slightly different, something that takes into account pre-existing velocity. But for the moment, I'm just gonna be like the controller is just gonna control velocity all the time. So the idea behind collide and slide at the end of the day is that this loop will give us a number of vectors. If we sum all of those vectors, we effectively get like the direction we actually have to go in. And then that will become the direction for the magnitude. And that should work out for us overall. So at the end, we will have a direction for final, but we're not accumulating anything here at the moment in terms of where we would need to go. So for example, if we were going to do this, if I can keep my controller in a spot, right? This would end up with a vector from our player in the bottom right to like the end over there. You don't need into inner, just dereference. You want to destructure the tuple of components, not a specific component. You see that Actum does it a lot. You pattern match in the args to destructure. Yes, but that's what into inner is doing, if I remember correctly. I don't think that that is substantially different. Docstar Bevy, single. Right. So this is self.item for single. Single doesn't implement anything. So it doesn't deref to anything. Here's the deref. It does deref to item. Or rather, it derefs to a shared reference of item, but close enough. There was an issue asking for that for res, and you say the answer is the same. Single has internal states, so you would need to destructure it also. It was probably undesirable in doing so. You just dislike both single.0 and single.1 or the extra let to get the individual components. Yeah, into inner is just the way that I've always done it. I don't know that deref is unintended, but into inner will give you ownership and deref will give you a shared reference, is my understanding. Writing code in YouTube comments, it'll be fine. It'll be fine. The formatting will work out. Yeah, you can deref, but when you deref, you get the shared reference. When you do into inner, you get the ownership, which should also be references. Everything is a reference. It would be nice. I've wanted that before. I just don't think it's currently possible. Never possible. Not what I'm saying, but not currently possible. Okay, spatial query characters. For each character, we get the velocity. It's linear velocity. We need to do this max hits for this over that. Which vector do we need to accumulate? We need to accumulate all of the color vectors, right? All of the use vectors. No, all of the use vectors. All of origin to this. Vec. Let's just do vec accumulation plus equals. What should we do here? Origin and first hit gizmo position. Probably this minus origin, but we already have that. It's first hit distance times direction. I think that's our vector, because we have to subtract origin from first hit gizmo position anyway, right? And we don't need the actual location, we just need the direction. So I think this is right. This is not, what do we say? Slide accumulation, we'll call this. And this will live outside of this. And we'll visualize this before we try to use it. This isn't doing any kind of like fancy function return or anything. It's literally just doing it. So this. We have slide accumulation from original origin. We will need original origin, which will be position 0, which we'll have. And this will be color white. It's fine. One day I'll remember how to write gizmos without looking at the thing that I just wrote 2 seconds ago. Especially with single, it feels like it should be possible. It feels like the entire single struct should just be a trait. I do think that of all of the potential use cases of that, I think that the single makes the most sense. Why is there no white vector here? It gives me the white vector where I expect to have it. It doesn't give it to me here. Which feels weird. I feel like I'm returning early. Hello, Callahan. How are you? What are you up to today? So this will just continue, and this continues outside controllers. But I don't really want to break out of that. I want to break out of this specifically. This is cast shape and print first hit, right? If we cast and we fail, I guess we're going to have to know that. So this is going to be inner, and the other one is inner as well. And then this should show for everything because I'm no longer returning from my, we always have that white angle now. So this is our full collide and slide visualization is what it is. So all of these end up going to the same place. This is unfortunate. I think we'll have to figure that out at some point, but close up also does it. Theoretically, if this was how fast we were moving, this is where we should be going. The white one is where we should be going. This will all be significantly smaller though. You most likely missed it, but why is linear velocity not usable for a character controller? I didn't say it wasn't usable. I wouldn't state it that strongly. I would say that of the people that I've seen working on kinematic character controllers, all of them have preferred to keep velocity on their own rather than let linear velocity be applied. And I don't think that that is like a hard truth. I don't think that's like some absolute fact that you can't use linear velocity. But the people building kinematic character controllers comprise a set of people who want control more than they want integration. So it doesn't surprise me that none of them are using it, right? If you were okay giving up some control, you might be using a dynamic character controller instead, right? A kinematic character controller kind of attracts the people who want to be very specific about things. And linear velocity has implicit behavior in the sense that if you set linear velocity, it will move your character. The question also becomes like, if you start setting linear velocity and it applies and it hits something, what does it do? So a lot of the kinematic character controller code that I'm seeing wants to predict a hit, not react to a hit, is the other thing that I'll say. Yeah, linear velocity gets automatically applied for kinematic bodies, but for move and slide, you want to use the velocity to manually compute the end position. So, stronger statement might be for collide and slide, it's not the right approach, right? If we're trying to implement this algorithm specifically, we don't want linear velocity for all of these things. But I could also see a world in which this is calculated and then we change linear velocity before it gets applied. So I don't necessarily think that's an absolute truth either. But you do have to be able to calculate it with the velocity anyway. So. Is it possible to assign velocity to Rapier colliders without the velocity actually affecting the collider itself? What would you, oh, you mean like if you had an immovable collider, but you wanted it to treat interactions like it was colliding with something? There is the collision hook stuff we looked at for the conveyors that we talked about earlier. You can't assign a velocity like as a component and have it like act like it's hitting something, but you can do the collision hook stuff that we were looking at earlier. Not gonna lie, sometimes people just don't intuitively know the difference in which character controller they want. Yeah, also, we were talking about it earlier, but the pedagogical material around what the implications are is really sparse. It's really difficult if you don't know what each of these rigid bodies are. And the full, like, I would say personally that if you haven't done a full integration of a dynamic character controller to like the fullest extent and done that for a kinematic character controller, and you've tried to push both of them as far as they can go, then you don't actually really know how far either of them can go, right? It's really tough. It's like there's a lot to handle if you take it on yourself with the kinematic, but it's very obvious that there's a lot if you take on the kinematic. With the dynamic, it's very easy to get lost in feeling like you don't have control because you don't understand the underlying physics system. So, yeah, I think that there's not a lot of good pedagogical material teaching what the end result of both of them could be, like in their idealized forms, anyway. Not gonna lie, I treat this entity as if it has moved by this velocity last frame without moving it. Feature could be nice for tons of things. You feel? It feels like that would be the first thing I would have reached for the platforms. Definitely would have been that, because I didn't really want to deal with the complexity of deriving the animation curves and trying to drive linear and angular velocity and making that have the physical effect. I just wanted the current behavior to do that anyway, like to behave as if it was doing that while I controlled the movement. But it also feels weird if you start getting into like, this should have that impact even though it's not doing that. So yeah, I don't know. I would hesitate to say that's a solution. But yeah. So at the end of the day, this is the direction that we need to go in. And we kind of just have the vector, right? So position plus side accumulation, which means that we need to modify this to use the linear velocity. And I think the linear velocity probably needs to get multiplied by time. No, this is in fixed update. So delta time is always going to be the same. Damn, another thing you want to try. That's what this is. This stream is just side projects. This stream is, did you want another side project? Well, come get it. We don't really need to multiply this by delta time. Because this runs in fixed update, the linear velocity like should just get set to whatever we want it to be for that, I guess. So it really just depends on how we want to define the linear velocity value. I think I will multiply it by time. Let's do current velocity, we'll call it. I think that we're casting in a direction from an origin. This max distance is the value that we're going to need. Right, so this linear velocity is implicitly driving this max value. You know what? F it, I'm trying it. Nice. You trying to implement Fortune's algorithm. You have a naive dynamic character controller and you want to be able to do slides and stuff. Should you start over with a kinematic? You mean like you want the character to be able to slide, like as an action. I don't think you need to switch anything for that. I could very easily imagine a dynamic character controller, if you were sliding, treating that as like restitution 0 for some length of time, and then putting restitution back to the default, like that kind of, not restitution, sorry, friction, friction and other things like that. I don't think you need to switch to implement slide. If you're not happy with the slide and you want to do the slide in a different way, that would be a reason to switch. But I don't think you have to switch styles of character controller just to implement a slide, right? You just need to set all the components such that your character is sliding, right? Which is things like friction, etc. We don't break out of this anymore, so let's get rid of the label. Linear velocity. This is, can we get a magnitude from this easily? Length. So we get an F32 here for current velocity. Probably worth debugging this out just for the moment. Current velocity, I don't think, trying to think about this. We're gonna slide along a wall. If we do the first collision, we are probably going to want to take some bit of that velocity out. And the remaining velocity will be the magnitude for the next shape cast. So I think we need to update current velocity somewhere. The question is where. It's the magnitude of the current velocity minus the hit distance. So maybe we do it here. All right, current velocity dot length. See, would this be distance over length? Distance over length gives us the percentage of the velocity that we used. I feel like there's going to be a better way to do this, but I'm going to start with this. First hit dot distance minus that. Used velocity percentage. Why is that? Oh, current velocity is the F32, right? So first hit distance minus current velocity magnitude is what we're going to call this. And then current velocity magnitude is basically this. Distance is t. Does it just come straight out of the cross? We aren't visualizing the the directional currently. Let's see, what do we have for visualizations? We have an infinite thing because I already swapped out the thing here. So this is going to be this. Let's cut it down a little bit maybe. So we visualize the normal, we visualize the up-down vector, we visualize the full distance to the next hit. But the vector that we get that is origin, first hit, distance, direction. I should put this in Bevy Inspector eGUI, but I'm just going to keep doing it like this because apparently I'm a masochist. So we have a velocity. We've got the magnitude of that velocity. We go in this direction. We hit something. The orange vector is the next direction we need to go in. And the amount of the velocity that we need to take off is the what? Am I wrong in thinking about it? I feel like we need to use velocity as a resource for our distance calculation because otherwise we just go forever, right? Is it just the magnitude minus the time? That feels so weird. That doesn't sound right. We get this vector is origin to the first hit. Then we cross that twice for the new direction. This new direction just happens because we decided to get normalized. But this is actually, I think, going to include the resulting part of that velocity. Maybe the amount of velocity you need to keep is the dot product of the input direction by the output direction multiplied by a restitution factor. Input, output, dot gives us the similarity. When they're similar, we basically do nothing. When they're very different, we basically do a lot. I think that sounds right. New direction comes from the next direction we're going to go in, but I want to visualize this for a second. And I think it's origin to position. The gizmo hit position. Plus the new direction. And this is going to be color black. And maybe we take this one out for a second so that we can actually see it. Message retracted. This. Right? That's how far we would go. Next. It doesn't feel right though. The further, yeah, actually it does. It does. The further we go to the right along this wall, the longer I think that gets. So if we show it here, yeah. The closer we get here, the less distance we have. The further we get that way, the more of the vector is left over because it's a glancing blow. So that new direction already includes the distance that we can go for the next one. So that is actually just the magnitude of the next vector, of the direction vector. See, visualizations. Yeah. Right, new direction dot length. This is the leftover velocity magnitude for the next iteration. So this is the current velocity magnitude equals that length. Why is that yellow? I don't like that that's yellow. Do we not use it? Is that why? So then we would put that here, theoretically. Run this. This will not be very much. Might not even be enough for us to visualize. Very much is 0. We're not setting it then, I feel like. Let's make sure we're setting it here. Oh, you know what? We're not setting it at all because what I did what did I do here? This is velocity is a 3-dimensional vector. Let's say let new velocity equals this, right? This is a vec2. We have the x and y. Velocity, let's do plus equals new velocity. That extend. It's not extend. Let's just say that this is it. You're just going to move one y, z, x is what we're using currently. Why is that an issue? Velocity.0. You kidding me? Okay, new velocity, expected mute, found vec3, mute, vec3. New velocity is a vec3. Or turns into a vec3, sorry. I don't like this. Absolutely that. Same thing that we were just talking about before. This extend is no longer necessary. This is velocity dot zero. This needs to be mute. We run this. This at least has a value, which is what we were looking for. Is assigning to 0 directly not buggy in Bevy? I don't think so. You thought there was something about the deref impl tracking stuff, or you misremembering? I don't think it's buggy. I haven't seen. I've watched every PR come in over the last year and a couple months. Like literally have read them all. So I don't remember seeing anything about assigning to 0 being buggy. I also use it all over the place, I think. If it is and you can find it, please share it, because that would be something that I would like to know. So all of this to say, casting happens. We have our slide accumulation. So really, slide accumulation is our velocity, right? Let's do something that is a little bit more. So it looks like there is a limit because this used to go all the way around, which is great. We do need this to be less than that. It shouldn't quite go that far. We'll say that is very fast is kind of the implication. So we're saying that this is 10 by 10 and that we're doing this in fairly small increments. Slide accumulation becomes 0 in that case. So the question is, slide accumulation, if it doesn't hit anything, probably just applies the built-in velocity, right? Because like if we don't hit anything, then slide accumulation needs to be something else. Slide accumulation should never start with the velocity, I don't think. I think it needs to start with 0. So if I equals 0, then we need to set slide accumulation equal to linear velocity. Does extend not exist there? Dot 0? That's fun. What is that doing? That is the wrong axis. I wrote the wrong axis. YZX? Linear velocity. Is linear velocity... KCC velocity, that's already... Yeah, okay. We don't need to do that. Okay, so this is the direction that we would want to go in, ideally. You don't want to know what direction I'm holding on my controller because it's not the right one. Theoretically, we're headed in that direction. You now realize that working with Avian main and reading 0.2 docs is a bad idea. You can do a cargo doc. I don't know if you've ever seen this. I don't know if you know about this. But if you do cargo doc, this will build all of the docs locally for everything in your application. That will put it into the target directory under target doc. There's a serve built into that command, but you can also just like Python serve it. At which point, if I go to localhost 8000 and I go to Avian 3D, or maybe I don't go to Avian 3D. Oh, right. I just started building this again. It cleared out. If I go to this error, this is just like whatever version of this error I'm using is there. So if you, yeah, -- open if you want to. I don't like things opening for me, so I'd never use it, but cargo doc -- open is definitely it. Especially if you're working with a bunch of stuff on main, highly suggested that you just build the docs locally. Yeah, right now you can just build crates.io, but like for future reference, you can build the docs for your local application locally and serve them, and that will give you any main branch docs that you wanted to look at for anything. So if you had a bunch of them, a bunch of different crates or whatever, you can always just browse the docs locally. That's actually something that I do. I'm going to get on a flight tomorrow. Cargo doc is something that I'm going to do before I get on the flight in a separate project so that I actually have access to the docs on the flight, even if the Wi-Fi isn't available. Okay, I want to change this to dot whatever. So scale down that vector a little bit so that we get to specify like the full thing, and then this is a little bit not enough. So I'm thinking, oop, that's not what I want to do. Now that I've run it. Will I live stream or vlog from the Netherlands? We'll be in Amsterdam for Rust Week. I'm not currently planning on it. I'm not against the idea, but I can't think of what I would do. The second thing is I haven't asked anybody that would be there if they would be comfortable being on camera. And that's really my big thing. I have a nice camera. I usually bring it to these events. with a mic and whatever. I usually record stuff for myself to get some practice in. But the one thing that I don't do is usually film conference areas, which is probably where I'll be spending most of my time, right? I could do a vlog. I've thought about doing vlogs before. I just need to figure out a format or like a style of doing it that feels authentic to me. I'm very much not like a, hey, everybody, kind of person. So I don't know. I gotta figure it out. If I'm gonna do a vlog, it'll probably be a recording. I want the opportunity to, you know, make sure that there's nobody in the videos that isn't, you know, whatever, things like that. I probably won't film it all inside of the conference area, which also makes it a little bit awkward because like then I'm vlogging and I'm not showing the conference. But yeah, anyway, that's the whole thing, right? There's going to be a Bevy event. I don't want to make people uncomfortable by having a camera around. But that doesn't mean that I won't make anything. I'm glad you're enjoying the videos, Mr. V. Okay, so let's make this actually move the character. This is slide accumulation, and this will be, where's our transform? We don't have a transform. We do now. Or maybe we do this after. I don't know. We'll just do it for here for now. But yeah, I've thought about doing devlogs and stuff too. I have a devlog format that I would like to try out. That is a little bit more vloggy, but translation. Slide accumulation. Is there a reason? Did I not specify this as mute? Is slide accumulation of magnitude? No. That should be a vec3. Oh, mute characters. Yeah, there we go. Which is also not mute in the query. I forgot to mute everything. Yeah, it makes sense. Do what feels right and be respectful of people's will to be on camera. Yeah. Yeah. I think that it's far more important to me personally. Oh my God, this is so fast. This is so fast. Oh God. Okay, that got us stuck. I need to greatly reduce the speed. Yeah, I do think about branching out and doing some other kinds of videos every once in a while. I think about what I could do on different channels and stuff even. Okay, so very obviously, not adding the final vector, I think. Let me test that theory. Feels a little too crunchy, but slide accumulation. Is slide accumulation too big? I feel like I don't even see the visuals. There we go. Definitely stuck in the wall. Oh, multiply it with a constant factor. You mean just to like... I mean, I was doing time to delta. It was a little bit slower than I wanted it to be. So we could do like time delta seconds times 3. Make it a little faster. Obviously, this is not going to stick around in our code here, but... I think that we're not adding the end velocity. Right? The current magnitude, right? But the slide accumulation. The slide accumulation, fine when we're not colliding with anything. When we return here or return here, we've already added the slide accumulation here. So if we get a successful shape cast, then we should be adding slide. Don't you finally want to mount the camera to the character? What do you mean by finally? Let's do this. Let's put this over here. Get a lot of those logs nice and long. So slide accumulation going towards 0. Add slide accumulation 0, 0, 0, 0. I feel like that's our issue. You just thought it might be easier to understand what happens when you see it from that direction? Like, you want to see it connected to the character? So for me personally, I understand what's happening. We're basically hitting that point. We aren't adding anything to that velocity, right? This slide accumulation is 0. So let's put this here. I think we're only effectively getting 1 hit's worth of accumulation. Right? Like, no matter what way we do this, it kind of just like hits there and sticks. And like, I feel like our characters should be, at this point, moving further. There should be more going on there. Because we're kind of getting stuck here, right? Having multiple debug cam views would be useful, but I didn't set that up yet. We could definitely set that up at some point. Like sticking a camera directly on top of the character and some stuff like that. I think that would be interesting. Right now, like, we don't see the vector at all. There's no visualization. I feel like that's stuck in the wall a little bit. I still feel like we should be able to go the other direction. But nothing is showing up here at all. So something is definitely just wrong in general. And this is definitely not adding anything. So just more stuff to do, basically. Can definitely pre-place the camera over here. This camera also wasn't like meant to be used like this. That's why it's so awkward for me to like bring it over here. I think we aren't using the skin width. I don't know that we included the skin width into these calculations here. I know that we were talking about it at one point. But the normal... Oh, we're moving the normal and the visualization. I don't think we're using the normal at all in the actual implementation. Here we go. First hit normal 1. So the origin, we're moving the origin for the next cast. But we're not taking this like skin width situation into consideration in any other place. So the algorithm is teleporting out a little bit each time. which actually makes me feel like if we don't account for that, then it's teleporting in a little bit each time. All right, this is the new origin. But by moving it out this far, one thing we could do just to test this is add that to our slide accumulation. We get very, very stuck. I feel like we should have more of the velocity. You're checking out the Avian Git repo. You'll be right back. Cool. I think we're about done for the day anyway. It's about 12. I've got to finish This Week in Bevy today, and I also have to play D&D later with my D&D group. So I've got a lot to do today. I think I'm going to increase this a little bit first and see if that's just a quick fix. Oh, that's not what I wanted to do. Like, this definitely gets stuck more than I want it to. And it does feel like it's like how do I say this? Like attracting into the wall, if that makes sense. So I'm definitely like not adding things in the right way. But that is an accumulation bug that I will have to figure out. The path where it's equals 0, then calculate the vector from the player to the point. What do you mean by the calculate the velocity you want to go without wall, then iterate over your path and subtract the total distance of segments from the initial velocity unless you are less than 0. Then take the point on the path where it's equal to 0. Then calculate the vector from the player to the point. Sorry, you're saying calculate the velocity you want to go without the wall. Then iterate over the path and subtract the total distance of segments from the original velocity until you are less than 0. Then take the point on the path where it's equals 0. So we have the velocity we want to go. We are iterating over the path. We are subtracting the stuff that we would need to subtract. The subtraction for the magnitude, I think, can go below 0. Linear velocity. Actually, we ended up not doing the subtraction. We ended up doing just the directional. You're saying that you think I need to solve for equals 0. What do you mean by what equals 0? New direction. So we have our direction. We have everything. Because remember, if we do the calculation, it does do the right calculation. Let's say if we did this at some ridiculously high number, right? Let's make this full screen. Where normal intended movement matches the one you're actually going to do. I don't know what you mean by normal intended movement matches the one you're actually going to do. I see a lot of like specifics that you're trying to get at, but I don't see. We're still visualizing the black bar. Or did we get rid of that? I think we got rid of that. Here we go. This is the issue right here. The vector gets smaller as we get closer to the collision area. And it gets very much smaller. I feel like we're losing the tail end of that velocity. Imagine if you don't have a wall. That's the normal movement. Okay. So like you mean if there's nothing at all. Yeah, cool. Straight vector. It looks like the input vector length is not the input velocity. The input velocity right? Linear velocity, this, collider origin direction, distance, it looks like it is more the length to the first collision, and this influences the output velocity calculations. You think the black visualization is the distance to the first, not what I have it visualizing at? So we've got new direction, right? First gizmo hit position plus new direction. New direction is that when we've hit a shape cast, right? Green arrow gives us the first hit gizmo position to the first hit gizmo position up. So this is the straight up down, right? For the place that we're going. The new direction is the cross with the normal and the up down. The new direction here, which we're getting the magnitude of, is the visualization of the black line. So the current velocity magnitude, the next one, is the new direction length. Current velocity magnitude. Current velocity magnitude. Yeah, it looks like your movement goes towards the collision. Yes, I said that earlier. If you get, I don't necessarily think it's like, how do I say this? Like it's supposed to go towards the collision on some level, right? But I don't think we get the full velocity that's supposed to be taking. Because as we get to the collision point here, the black line is getting significantly smaller. Black line is supposed to be the leftover. I've now messed up because we don't have gravity from going over those platforms. Right? Like even if I'm doing this, it goes to that first hit point, and as we get closer, the black line gets smaller. The black line should not get smaller. right? This new direction should not get smaller. The white arrow should have a length that is a velocity and not be smaller if the collision is nearer. Yeah, the white arrow should be towards the slid point. That's kind of what I'm saying here, right? The white, let's see, where's white? White is here. This is the slide accumulation. That's what I'm saying. Like, I don't think we're adding the end. I don't think we're adding the black to the white, right? I think we're losing velocity because we're not adding the black vector. Right? This is the effectively, which is effectively new direction. So new direction is the current velocity magnitude. Slide accumulation, new direction. I guess we aren't adding slide accumulation in the right way. So slide accumulation for each iteration is the hit distance times the direction. But if there's no hit, that's the situation in which we aren't adding. If there's no hit, we're just setting slide accumulation here. This is no hit, right? Right here, this is no hit. So then it would be slide accumulation plus equals the new direction, which would be not something we're storing at that point. Right? New direction is not something that we are putting anywhere, but we probably should. Let's hang on to it. Right? New direction here. And then if we have no hit, we add new direction. If I can figure out how to do this. What did we say new direction was up here? I didn't say anything, did I? New direction is vec3, 0. New direction down here. New direction here. Let's do this. New direction equals the cross, which all ends up working out. And then this becomes a compiler because I misspelled slide accumulation, not because there was anything wrong. Woo, Avian 0.3. Let me. Yeah, I would have to slow that down. This is way too long in terms of like the velocity that we are showing here is definitely the wrong amount. It's too much velocity, but we are now getting a better result. So we were missing that last component. You still think if there's a hit, the new direction is calculated with a vector that's too small? New direction is the black vector. So you think that the like in this situation, yeah, I mean, I don't even see it visualized in that situation, right? This is pointing the velocity basically parallel. It's definitely sliding. There's definitely something wrong with it, but it's definitely sliding. You think it's fixed now? I think the black one here should probably be longer. Right? Like this is the length of the regular speed, right? Which is pretty long. And if you end up here, where's the visualization for the black vector? Should be pretty long, right? Right, like here, the black vector should be pretty long horizontally. So there's definitely still something wrong. Some kind of wall run hook, wall run mechanic, just a kinematic character controller. We're doing collide and slide right now. Debugging my vector accumulation logic. We went over a whole Avian 0.3 release notes kind of thing at the beginning of the stream. And I'm just kind of like wrapping it up here in a second. I felt the hunger hit just now. Gizmo minus long origin has a length proportional to the distance to the first collision, not the velocity. So you think new direction is the wrong value? So we've got the hit location and the origin subtracted. So we've got the vector from where we are to the new place crossed with the hit normal, which is vertical, right? So that's the green visualization. Crossed with the normal. Or the normal crossed with the up-down vector. Gives us the direction. That direction is what we're visualizing. So we're losing velocity because we're not using velocity here at all, actually. $246, $247, yeah. The gizmo position minus origin has a length proportional to the distance to the first collision, not the velocity. Yes. So the question is, how do we maintain that velocity? because this is just the vector. This is the distance vector from where we are to where we're going, or to our first collision. I'm going to be honest, I don't know what you mean by solve for zero. You've said it a couple of times now, but I don't know what you mean by solve for zero. You think we have to normalize it? I want to say that I feel like we don't have to normalize it. I'll definitely try this. What are we calling it at this point? This is the linear velocity. Is that what we decided to keep calling it? Yeah. I guess we can do it by the magnitude, right? Okay, and now we need to reduce the speed quite a bit because now we're actually sliding. That's way too slow. So this is doing the right thing on the wall now. I just need to get the magnitude correct, especially relative to like the speed you can go off the wall. This is the speed you can go off the wall. I am not properly making this happen, but at least on the wall, this feels good. Okay, let's see what Roland had to say. Loop over the paths. We are doing that. Determine the point where the length of the path matches the original distance it would have gone. This point, the player position minus the player position, is the new velocity. Yeah, you're describing what we already did though. Right? Like we are looping over the paths. We are accumulating those vectors. But none of those were the issue, right? Because the way that we're doing it now, sure, it's uncapped, which means that it's what's happening on the wall there, right? But that wasn't the issue that we were having, right? Because we were already doing that. We were already accumulating those vectors. We were already figuring all of that out. And yours would be a shortening of the velocity, not a lengthening. And we needed it to lengthen. In your opinion, magnitude should be 1, but the calculation of vector amplitude should be more right. Maybe something not normalized when it should be for cross dot products. Yeah. I think that the speed at which we go on the wall now is wrong compared to the speed at which we go off the wall. But the calculation that is actually happening in the sense of how the interaction with the wall behaves is correct. So now it's a matter of going back to what Roland was saying. Now it's a matter of making sure that we have the correct amounts of stuff. But the issue before was that we were getting stuck on every wall, not that we were not limiting the velocity enough. Because right now this is speed off wall. This is full speed off wall, just ripping and roaring here. And then because I'm multiplying by that magnitude, if you're on wall, that vector is actually probably adding more velocity. But it's behaving correctly now. We can go back and forth along the wall. This vector is just going like into and out of the wall right now. I'm just moving in like a half circle on the controller. So generally speaking, happy with that. Obviously more work to do, but relatively happy with that for the day. I need to get a sandwich or something because it's about that time. It's half an hour past that time for me. Try the ramp. We can try the ramp. There's no gravity. So the ramp is not going to have a reasonable behavior. It's just going to push the collider up. We haven't implemented a gravity pass yet. Whee! You can speed up the ramp. You, however, cannot get down once you're in the air. Yeah, for multiple collisions in one sim step. You thought that was the goal since we calculated multiple steps. Yeah, I think that your stuff comes in now. It wasn't what we were doing before, but I think the stuff you were just talking about comes in now. Character controller should not care about if the physics engine has continuous collision detection and for games not accurate simulation. You've been fighting with your sub-second iterative compiles being delayed by something in Rust Analyzer ignoring cargo target dir and still locking the main target, therefore delaying bake and run. Tooling issues. Yeah, I've been having some issues with Rust Analyzer. Me and Rust Analyzer are not the best of friends at the moment. I feel like every time I want to run cargo run, Rust Analyzer is locking that directory right now. I'm thinking about doing something a little bit more global with my cargo target directories and stuff, or just moving. I know you can remove Rust Analyzer into a different directory. I might do that. But yeah. Anyway, that's it for today, y'all. Thanks for hanging out. I'll catch you in the next one. We are not going to have a stream next week. No Monday stream, no Saturday stream. I'm going to be at Rust Week I'll be there Sunday to Sunday. We might have a Monday stream that week. But yeah. Yeah, here all got more slow recently. My stuff got slower recently, like over the last few weeks or like that last month or two, for sure. And I've noticed it. I don't know why it is exactly. I need to figure it out. Yeah, your starter repo is configured for fast incremental compiles, right? You've moved everything global, and Rust Analyzer and a subdir is just not accepting it. Yeah. Anyway, that's it for today. Thanks, everyone. I'll catch you not this week, but next week.